just referred to on the basis of his own personal experiences and observations. I'd also like to highlight our findings related to extreme events, and I would now mention just a few as an example. The frequency of heavy precipitation events has increased over most areas. Then from 1900 to 2005, precipitation increased significantly in eastern parts of North and South America, Northern Europe, and Northern and Central Asia, but it declined in the Sahel, the Mediterranean, Southern Africa, and parts of Southern Asia. And globally, the area affected by drought has likely increased since the 1970s. There is now higher confidence that in the third assessment report, in projected patterns of warming and other regional scale features, including changes in wind patterns, precipitation, and some aspects of extremes and sea ice. The rate of global average sea level rise has risen from 1.8 millimeters per year to 3.1 millimeters per year from 1961 to 1993. The reasons for sea level rise has been due to thermal expansion, melting glaciers and ice caps, and the polar ice sheets. Projected sea level rise at the end of the 21st century will be in the range 18 to 59 centimeters. It's projected to be in the range of 18 to 59 centimeters. Human-induced warming would lead to some impacts that are abrupt or irreversible, and these include partial loss of ice sheets on ice polar land, which could imply meters of sea level rise, major changes in coastlines and inundation of low-lying areas, great effects in river deltas and low-lying islands, and approximately 20 to 30% of species assessed so far are likely to be at increased risk of extinction. The large-scale and persistent changes in the meridional overturning circulation, referred to as the MOC, will have impacts on marine ecosystem productivity, fisheries, ocean CO2 uptake, and terrestrial vegetation. Fortunately, humanity has within its reach a number of solutions, some of which are related to our perception of problems and attendant solutions, and our ability to put in place policy measures that would facilitate the implementation of those solutions. A wide variety of policies and instruments are available to governments to create the incentives for mitigation action. Stabilization levels assessed can be achieved by deployment of a portfolio of technologies that are either currently available or expected to be commercialized in the coming decades. And an effective carbon price signal could realize significant mitigation potential in all sectors. So this is an important finding. If we want action, then clearly there has to be a price attached to carbon which will move us towards a low-carbon economy. This is just a picture of some of the potential mitigation results that one could achieve by 2030. And each of these is linked to a specific price on carbon, which is indicated here in the diagram. And you can see the significant differences for mitigation in several sectors based on the price and the differential in prices for carbon. The macroeconomic costs of mitigation generally rise with the stringency of the stabilization target. However, in 2050, global average macroeconomic costs for mitigation towards stabilization between 710 and 445 parts per million of CO2 equivalent would be between a 1% gain in the actual output of goods and services and a 5.5% decrease of global GDP. But slowing average annual global GDP growth will be less than 0.12% if we were to stabilize at between 445 parts per million and a somewhat higher range above that of CO2 equivalent. Now, I'd like to raise an important issue that's part of the UN Framework Convention on Climate Change, and that's the issue of what constitutes dangerous anthropogenic interference with the climate system, because this is the core of the Framework Convention on Climate Change. Here I want to bring to your attention an important finding from the synthesis report. If you look at the first row of numbers over here, if we were to stabilize CO2 concentration at 350 to 400 parts per million, which translates into CO2 equivalent concentration of 445 to 490 parts per million, you would notice that you would get an equilibrium increase of temperature between 2 to 2.4 degrees centigrade. Now, this may not happen in the 21st century, it may happen somewhat later, but implied with this and inherent in this is an increase of sea level above pre-industrial at equilibrium from thermal expansion only, which is in the range of 0.4 to 1.4 meters. Now, this is an extremely serious finding, which clearly establishes that with our actions and placed as we are today with the concentration of greenhouse gases in the Earth's atmosphere, we have already committed the world to experiencing a sea level rise to thermal action, due to thermal expansion alone, to the number that's mentioned over here. Now, if you add to this the melting of all the ice bodies on the Earth, that clearly gives you a picture of the kinds of problems that we're likely to face. But this in itself is quite serious, as you would notice. Now, I'd also like to raise some equity issues. The impacts of climate change are not going to be felt uniformly. For instance, in Africa, between 75 to 250 million people are projected to be exposed to increased water stress. This will be by 2020. And in some countries, yields from rain-fed agriculture would be reduced by 50%. And in Asia, you have problems of freshwater availability, coastal areas being affected, particularly the mega-delta regions, which are really at the highest risk from sea flooding. And the small island states are particularly vulnerable because they would not only suffer from inundation, storm surge, erosion, and other such hazards, but also by mid-century, reduced water resources in many small island states will make it impossible for them to meet their own needs for water. Now, these are questions that I have framed as an individual. There are some science and some leading questions